A viewer writes, "You make me mad. Every time you want to prove something, you use the machine with the green wiggly line. I don't even know what that thing is, let alone what it's supposed to prove." Angry, Exeter, Ontario. Okay, Angry, calm down. You're right. Every time I resort to the oscilloscope display of something, I'm kind of a little mad at myself for not taking the time to fully explain what's going on. Oscilloscopes are the most useful of all measuring devices, and a good scope can replace all other pieces of measuring equipment. Here's a project. I wanted to know how a battery would discharge with a particular light bulb connected. So I took my trusty voltmeter and made a chart of battery voltage against time. Time goes this way on my graph and voltage goes this way. The line there was the result of my readings taken every 15 minutes. What's this got to do with an oscilloscope? Well, that's all they do, plot voltage against time. The reason you can't replace a scope with a meter and a stopwatch is that most things in electronics just happen too quickly. The heart of the oscilloscope is a cathode ray tube. It's a lot like the one you're watching me on right now. A thing called an electron gun at the rear shoots a focused beam of electrons towards a coating on the front face that glows when those electrons hit it. Now, by changing the voltage potential on some little metal plates at the back, the beam can be bent. And the direction of the beam can be changed very rapidly because the stream of electrons has no mass, or very little mass, or maybe they haven't decided yet how much mass an electron has, but anyway, as far as the cathode ray tube and the Acme service desk are concerned, electrons have no mass. Don't write in. The rest of the stuff inside the oscilloscope is involved with bending that beam very accurately. The signals you supply to the scope move the spot up and down. The front panel has a knob that controls the scale factor of that. The amplifier in this scope has a frequency response that makes the best hi-fi amplifiers look sick, 0 to 100 megacycles. The high end of that specification means that that spot will faithfully follow up and down a voltage that changes up to 100 million times a second. The low end of that specification, 0, means that the spot will move on the scale to show a steady voltage that doesn't even change at all. In other words, a 1.5 volt cell will deflect the spot 1.5 scale divisions when the scale is set for 1 volt per division. Now, so far, this makes the scope just sort of a very accurate voltmeter. And if that's all it did, it'd be a pretty dull machine. Up and down is fun, but left and right with up and down gets useful. The spot's deflected side to side by a circuit called a time base. On this scope, the slowest scale time is ½ second per scale division. The fastest is 50 billionths of a second. To make nice steady pictures, the time base has a feature called triggering. When the triggering is properly set, the beam only starts its trace when a predetermined voltage level is present. This lets the beams begin tracing the same spot on the waveform every time, turning rapidly occurring electronic events into a nice steady picture. When it comes to electronic events, a picture is worth 1,000 other measurements. This is a 1,000 cycle square wave. It's caused by a voltage that rises sharply to a value and then holds there for a while, then plunges to another value and holds there for a while. The rapidly rising edge requires good high frequency response, and the holding periods require good low frequency response. This signal's coming to the scope by the way of an equalizer, the same as the one you might have on your stereo. Here's the effect of a low frequency cut. The ledges on the square waves tilt. The graphical display shows exactly what's going on. The circuitry is happy with that rapid change, but it can't hold its output voltage at one spot for an extended length of time. Now, here's the reverse, a high frequency cut. Now the ledges are okay, but the circuitry just can't cope with that rapidly rising edge. The exact extent of these defects can be measured on the scope, but just standing back and looking at the overall picture gives a very good feeling for how the circuitry is behaving. Now, there are a million other neat tricks that an oscilloscope can do, but lucky for you, they won't give me the time to go into them. So, Angry, don't get mad next time you see an oscilloscope. The information on their displays is easy to interpret and a very real way to see and understand electronic things. Trust me.